Okay. Each group has hot water. Do you have cold water? Now, can we follow the procedure?
yetu sisi tunafaa tuko pamoja, kila mtu ako na
So, within the 5 minutes, make sure you are making an observation. Get to see what is happening. Are we there? So I want you to make a comparison between the two beakers, what is happening, and at what rate. Now, sir? Yes. The beaker that has hot water, we can call it beaker X, and the one that has cold water, we can call it beaker Y. So we make an observation and look at what is happening in beaker X, that is the one that has cold water, and then beaker Y, which has warm water. Are our 5 minutes over?
No.
Are they over?
No. Hot water the difference. Cold water the
Are we through? So 5 minutes are over, please. Can we go through our observation? So each group is going to give us a response. Huh? Yes. So what's up? Yes. Good. Okay, now group 1, what is your observation from your experiment? Anybody in group 1? Yes. What is your observation? Group 1 bado anafikiria which group is ready? Group 2? How did you know that it is diffusion that is faster? Can you tell us what you have seen? Just wait, give him time. Yes? So the one in hot water has turned the color faster than the one in group 3. Group 3. Yes, sir. What have you observed?
The one with hot water dissolves faster than that in the cold water.
The one with cold water is so faster than the one with hot is so faster than the one with cold water. Now can we clap for ourselves? That's good. Yes, do we have someone else to answer this one? Fiona. Yes, Amolam. Which content? Energy. Are we able to see the energy itself? It makes the molecules to move. So that tells us that there is something that happens when we have high temperatures, isn't it? Yes, that is what he's trying to tell us. So actually the observation is we can note in our sheets, in those worksheets, we can note this, that in the beaker with hot water, in the beaker with the hot water, in the beaker with hot water, the color changes faster. In the beaker with hot water, the color changes faster. And then the beaker with cold water, beaker with cold water, it takes too long for the color to change. It takes too long for the color to change. That's the first observation, right? And then I want somebody to look at their beakers. Look at the spread of the tea in those tea bags from the bottom to the top of the water. Alafu uangalie ile ingine yenye iko na maji baridi, isn't it? And tell me, what can you see? What comparison can you make between the two? Yes? They are on the same level.
No.
On the same level? Yes, Amase? It's not that highly concentrated. And then if you observe initially, you will realize that in the beaker with cold water, the color just changes at the bottom of the beaker. And it takes too long for those molecules to move upwards. Did we see that? Yes. Very good. And then in that beaker in which we have hot water, once we have the color change, we have the spread of those molecules. So, very good. Now, what does that tell you about diffusion? The first thing we should learn from that experiment is that the molecules actually move from a region of high concentration to a region of low concentration. Are you clear? That's why we had a higher concentration at the bottom and a lower concentration as you come upwards. And then the molecules move from the bottom upwards. Are you clear? And then the other thing I want us to note, given that we have observed that we have a faster change in the beaker containing hot water, we now note that temperature affects the rate of diffusion. Temperature affects the rate of diffusion. Are we there? And then now may I ask this question. In which temperatures do we have a higher rate of diffusion? In what kind of temperature do we have a higher rate of diffusion? In a high temperature. So high temperatures or an increase in temperature increases the rate of diffusion. That's another point to note. An increase in temperature increases the rate of diffusion. Sounds up. Now, how can you explain that? We now bring in the idea that Hemolem was given, right? Are we together? So when we have high temperature, the high temperature increases the kinetic energy of the diffusing molecules. High temperature increases the kinetic energy. Kinetic, K-I-N-T-I-C. High temperature increases the kinetic energy of the diffusing molecules. Therefore, increasing the rate of diffusion. Are you together? So that is what I wanted us to learn from that experiment. And now I want us to conclude our lesson so fast, if we have noted those points down. And I will ask questions at random, because we've known the definition of diffusion, you've known the factors that affect the rate of diffusion, and we've seen how temperature affects the rate of diffusion. So quickly, what is diffusion? What is diffusion? Yes, everybody? The movement of molecules from a region of high concentration to a region of low concentration. Very good. Can we state the 5 factors that affect the rate of diffusion? Yes, we have our student there. Temperature. Yes. Zeruya. Yes. Type of medium or type of diffusing molecules. Alani. Diffusion gradient, Emolem. Surface area. Yes. The thickness of the membrane. So, now in our experiment, what shows or what represents the cell membrane in a cell? In our experiment, ni nini inafanana na cell membrane? Yes? The T-bar, isn't it? Are we all agreed? Yes. Because it can allow the movement of molecules in and out, isn't it? That's why the T molecules can move from the T bag into the water in the water. Yes. So thank you very much for attending this good lesson. Now may I welcome our students who joined us for the lesson to make a few comments as we finish. Colleague, what can you say about the lesson?
The lesson was so good so far, and I think we've learned a lot. We've learned diffusion, what is diffusion. We've learned how the cell membrane diffuses instead of the water. I'm happy. The lesson was so nice. We engaged ourselves, and I'm happy.
So there is that aspect of engagement. So assuming you are the one to attend the lesson and we give you an exam.
Me?
Yes.
Okay, pardon?
Assuming you are the one attending the lesson and now we give you the exam on the same aspect that you've gone through.
Yes.
How will you find the questions? Easy, hard?
So easy.
Yes.
In the first place, we have understood the questions, all of us, and we can tackle it.
You can tackle them. So the concept is grasped. One more person? Just a comment? Malum, say something.
The lesson was nice. We've understood diffusion, definition of diffusion, the factors that affect diffusion, and we've learned more from practical. We've seen, we've observed, and we've recorded what we've seen.
So that was good. Thank you very much. So thank you. I think now for our students, that marks the end of our lesson. And maybe for colleagues, now these one students, you can close your ears as teachers listen to me. Or I allow you to go out and talk.